Hello everybody and welcome to application Hickory Dickory Docker. Now you may not all be familiar with this that the internet says is one of the most recognizable nursery rhymes in the English language. Hickory Dickory Docker. I added this last bit myself, but the point of this nursery rhyme was to teach you how to count. I'm not here to teach you anything, much less to count. However, I'm here to share with you the insights coming from the experience of containerizing applications with, of course, our favorite tool, infrastructure, piece of software, call it whatever you want, Docker. We have quite the program for you, so sit tight, relax, and or enjoy our lovely table of contents here. We will have, of course, your mandatory introduction. I will speak just a little bit about myself, and I want to know about you as well. We will, of course, have a little bit of theory, just some explanation, key concepts, and any lecture would be remiss if it didn't include a little bit of dry knowledge, which I hope will not be too boring. Then we will, of course, delve into the implementation itself, giving you maybe the ins and outs, not to go into too much detail, but of course, the minimum basic requirements or what is needed so that you can actually relate to your case should you go through one of these tasks as well. Part number 4, I do believe maybe the part where you take the most value out of this session, where we will go through some details on the troubleshooting, what things you may expect, some hurdles, some even traps. Docker is amazing, but not exactly the easiest, as I hope we all agree. And last but not least, if we cannot have a Q&A, I will go into some further considerations trying to anticipate what you may encounter as well and give you some pointers. Even if I can't demonstrate or enter a dialogue with you, except for the chat box, at least I will share some pointers so that you can know where to look for in terms of future directions. Let's kick things off then by starting with introductions. Let me remove myself from your screens and upgrading maybe to a bigger version. So before I actually introduce myself, I want you to get ready to introduce yourself to me as well, if you could, by using our chat box and just writing down, please, if you could. Your name must be accompanying you for sure as you write, so I would love to know your job title, if that even means anything these days, and it would be nice for me to know your level of experience with Docker. Let's say from 1 to 3, as in 1 being a novice, you go intermediate with a 2, and 3 you'd be an experienced or an expert, you could claim it. Feel free to also let us know the company you work for. So as you indulge in sharing with me the same as I'm sharing with you, let me thank you, by the way, for being here. My name is then Daniel Fonseca. I work for NFON, a German company operating in the UCaaS space, Unified Communication as a Service, and it's a company with more than 50,000 customers operating in 15 countries in Europe at the moment. I am a backend Golang engineer, and I consider myself to be Docker experience level 3. My claim to fame is that I've had Docker referenced on my CV since 2014 when I immigrated to London, and now I'm back to Portugal, or I'm back in Portugal, where NFON has its R&D department in Lisbon. Let's get this party started now, shall we? Here I am back with you. So The theory goes that, of course, containers are not a new thing. Almost it reminds me of 3D printing, that we all think it's a new thing, but it's actually been around for quite a while. Let me demonstrate that to you, just to give you some background. LXC Linux containers have been around since 2008 with the kernel version 2.6.24, actually, if you want to know the detail. Docker, which was known as .cloud at the time, it became open source in 2013. Now, what exactly is a container anyway, right? And how does it differ from a VM? I'm pretty sure you must all know what VMs are and VMware and what a container is, but you may not know the exact definition of it or where do they differ if you don't think about it too much. The big difference, in my view, is that you get a full OS with a VM. So, of course, obviously, you can run multiple OSs on the same host with a VM, whereas a container is more specific, but with that, let's call it limitation, you get higher efficiency of everything, mostly resources, memory allocation, and even, of course, disk space. So why would I want to have a container anyway, or several of them? Well, I could give you many examples, but the one that comes to mind would be you want to abstract uh, your application, for example, which is actually the topic that brings us here, right? You want to be able to distribute your application. If you distribute it in a container, then you get the warranty or the safe assumption that it will just work uh, much because you can include all the dependencies that it relies on instead of having to have someone install the OS and then packaging all that is needed, the requirements for that application or that ecosystem, right? Uh, Let me follow my slides and ask you the question myself. Can containers work together with VMs? Absolutely, of course they can. It's kind of a niche need, maybe, but there's nothing stopping them from coexisting, having a happy life together. Now, the other question is, are VMs going the way of the dodo, which, is a famous animal that became extinct? I personally don't think so. It's just that they're different animals, to continue using the example. VMs have their application. They are certainly required in that other world of proprietary software of that OS. We may know what I'm talking about. And yeah, I personally don't see that coming to an end anytime soon, but what I do see is the explosion, in a good way, of containers and us using them more and more. As I'm trying to demonstrate here, you can pick up an application and containerizing it, and of course we all know the current trend of microservices, so containers lend themselves really nicely to that. Docker Swarm allows you to cluster all these things, so it's a nice, beautiful world of containers without meaning that everything else goes extinct. Now, a little bit of a mention of the topic on portability of code versus portability of infrastructure. I don't want to get too much into the detail of this, but you may understand the way we favor now the portability of infrastructure versus the portability of code, since we want speed, we want efficiency, and you don't really get that so much with the portability of code if we think about Java. Of course, me being a Golang programmer, we understand how nicely portable Go is, but it's compiled, and so I'm not sure if you all know this. Docker is built on Go, which makes the Go community really proud, and you can actually compile for different platforms from the one you're working on. So I am on a Mac, and I actually can produce a Go executable or a binary for Linux. Right, we've done the theory bit, and we get to the more dynamic part of this session, the implementation. I even created a nice animated GIF for you here with some of my actual Docker desktop screenshots. There's Portainer there, and we'll get into that later on. For now, gathering list of requirements. Now, what do I mean by that? Is this more theory, Daniel? Well, you should know your application requirements, right? If not, it's easy to gather them or do that exercise. Why are they important? Because if you understand that containers run very bare minimal versions of everything, you might not have all that you need. But that's okay. Why? Because not only you can select the right image, like I wrote in there, you can also make it your own. The point is, knowing your requirements would allow you to do a good job in making sure your application has all that it needs. Now, if you don't have everything on that image, it's not a problem. You can have Docker install everything for you and, of course, run commands. What we want is to make sure that you know what your application needs so that it doesn't fail for some reason in the future. Now, what if something happens? Well, it would be nice to debug your application within a container, right? Maybe you didn't know that was possible. It's still a beta functionality, but I will give you a quick presentation on how it's done. So, shall we get to the action and see proper screens of proper Docker instead of just keynote presentation and this boring face? Let's go. So here we are, Docker desktop in its might, and I'm not going to delve into much detail about this application we're containerizing, or sorry, we've containerized. I planned just to show you a little bit of how it was done and where it could apply to your case, and of course, taking into account the lessons that we learn from each other and the internet. So just to give you a bit of context, this is an API that connects to a couple of databases that we can see here. And what you may be interesting for me to show you is the actual files that we used. Of course, your YAML for the Docker Compose, you can see here, I will be highlighting with my mouse the important bits. So the host name is an interesting one where you might not know that Docker actually has its own DNS system. So when you're developing your application, some people even rely on some Etsy host tricks. And so you might interest you to know that Docker actually has its own DNS server. And so you can do some nice funky tricks by just calling a host by its name, and it will actually ping and of course connect. Now, the other bit that might interest you as well is on the port connection. So whereas you would have your normal MySQL, for example, running on your port 3306, you can map it into any kind of specific port that you wish to do so, because of course you will have a limited number of ports on your host machine, right? So in this case, one of the databases maps to 8306 and the other one to 8406. There's also plenty of stuff in here to dissect, but just memory limitations, all of that. And my other highlight is, of course, on the networks. You would want to have them on the same, what we call VLAN or segment, and this is the place where you can do that. This is actually the Tomcat server itself, so you may realize here the port mapping as well is done for it. This is always an essential need, and you can actually even give some dependencies for it. This is nothing more interesting to see here, and we can go to the Docker file itself. Now, this is the meat of the question. You tell the image that you based, like I mentioned before, studying your prerequisites or your application requirements is important, but not fundamental that the image has all of them. So you can see here how we actually do an installation of the prerequisites by when we use this Alpine image. We then need to do some APK extra work on it, and then the most interesting bit, I would say, is when we then install the requirements in as in Catalina. So for the Tomcat, where we don't expect an image to be perfect, we tried and tuned different versions. Well, I myself, I even tried to see if versions above 7 would work. We kind of knew that they told us that it required Tomcat 7. If you understand that what we only received was what they call the WAR file. It's basically a zip file with all the application, but we don't have even source code. And this seemed to do the trick. So we set up an environment where we would get the tar.gz for it, and then we do, of course, a simple set of instructions. It's almost, you would think, like a script that runs these instructions, and then all is working. So that's the basic setup, right? For the application itself, what you could call as assets, you can use the copy command to have them placed on the container, your newly found container. You can tell what ports to expose from the local running container. If you remember, we were exposing 8080 and mapping it to a different port. And then the CMD keyword for Docker tells it which command to start the Docker image with. So essentially it would be a startup shell script, as you can see here. And this is the mapping from 8086 to 8080. Now all this is fine and dandy, but it's also nice to see the machine working, the container in this case, and you can actually go through the log files. Well, it's the console that you get here. Now let me show you some interesting tricks. Of course, you might know your docker ps command. Everybody knows that, but what if I told you, much like there's, the famous htop that I hope you're all familiar with, there's this amazing program called ctop. You can, on the Mac, of course, brew install ctop, and it, just quickly, not to waste too much of your time, let me just show you what interesting things it can do for you. Of course, you can always go Docker desktop and get things from here, but I would love to show you ctop for what it's worth. Of course, another trick you can do, of course, is running the CLI from here. And here's another trick for you. Docker uses bin sh default. You can quit from that shell and just run bash. It's a much better shell if the image has it, if you think that you can reutilize commands whereas the other one doesn't have it. So let me also show you the dev environment I mentioned before in my presentation, where the idea is to open VS Code directly from Docker. It becomes essential that we can debug applications, right? So not the example that I was talking about because it's no source code, but this is the interesting bit where you can actually run VS Code from within your container. I will tell you on the troubleshooting bit some issues that we had, and you could only notice them by debugging it running on the container, because the app is supposed to have the same behavior, right? But there's certainly unknowns that you will encounter when trying to containerize your application, and so debugging from within the environment, the containerized environment, is the only way that I know of to do it faster. Let me show you some quick extensions that I'm using. Portainer is the best one, where you can actually get your environment and see all that it has. It's very detailed. I'm back again, and let's go back to the shell to show you a bit of that DNS trickery I was telling you about. So we are now inside a container. I've made the font bigger for you, and you can realize the IP address of the container is here. Now, Docker doesn't always guarantee the same IP address, of course, but it will come from a range. That range can also be defined and or changed. Now, the interesting bit here is that you have to be careful so that the internal IP address of the container doesn't somehow clash or get in the way of your other internal networks. It's a funny true story that here at NFON we have to override, I think Docker's default is 172.17, which collides with our own internal network, so we actually had to override that. In terms of DNS, as I was saying, you can see the resolve conf here, where it does the magic from Docker itself. And if I show you my Etsy hosts, you can see this host here, and I will ping one of the other ones, mentioning it by name. Let me get this up here. You can see DB private is actually pinging, and of course it doesn't always get the same IP address, but if you use a name, you can see it resolving here that it's a proper DNS at work. So it's a great feature from Docker. Now, another interesting bit on the troubleshooting side of things is that one thing that happened to one of our applications that we containerized is that it was actually failing on the MySQL connections. It's not that it wasn't connecting, so it was really hard to troubleshoot. It was creating so many connections that MySQL would actually not work. It would start working and then it would bomb out. Now, the funny thing is that this is an application that was working fine in the real world, in the non-containerized world, but it was one of the issues that caught us off guard, and we had to do our best to debug and fix it. And we're back to the slides. I hope you enjoyed this session. The only purpose is to give you a bit of an appetite on containerizing your application for the future. And I hope you keep enjoying all Docker sessions, enjoying Docker, or starting with Docker. And it's a thank you from me, and feel free to write any comment you have. Feedback is welcome, beers as well, on the chat box. And I will see you next time.